In this section, it's about solving quadratics. So there are different methods to solve quadratics. I'm going to list off the different methods that you can do. So you can do the square root method. So the square root method is when there's no b term. It's the simplest one. So for example, if you had 2x squared equals 64, you would divide by 2 and then take the square root. So x equals plus or minus the square root of 32 and then break it down. You could break that down. The second method is to solve by factoring. So you're going to use the zero product property. So you get one side equal to 0 and then you factor it by greatest common factor, difference of squares, factors of c that add up to b. Factoring only works if you can factor it. Another way you can do is completing the square, which there's a couple of examples down halfway down through the page, so I'll do that. You can also solve by graphing, which you'll use graphing calculators and see where the parabola crosses the x-axis. And then the last way that works every single time is to use the quadratic formula. So the quadratic formula is long, but it works every time. So on this part, factoring, you can solve by different methods, but you can only use a method that's going to work for this. So if I'm looking at this one, the way I would do it was you have something that's being squared, like this whole quantity is being squared. So really, you could divide both sides by 4. So you're going to get x minus 2 squared equals 32 divided by 4, which is 8. So then I can get rid of this square by taking the square root of both sides. So what I'm going to do is I'm going to have two equations to solve. I'm going to have x minus 2 equals positive root 8 and x minus 2 equals negative root 8. Now I can do that because remember, when you take the square root, you're going to have two answers like I did up here. So if we break root 8 down, because you always want to break it down, it's 2 root 2. So I'm going to have x minus 2 equals positive 2 root 2. So I'm going to add 2 to each side. So x equals 2 root 2 plus 2. And you can't combine those two because these are not like terms. Then I'm going to change this one to negative 2 root 2. And you're going to add 2 to each side. So here are your two answers. And then 28. So this one, I can't use the square root method because I have this b term right here. So I'm going to solve by factoring. I'm going to try to factor. So I factor out a 2 first, a greatest common factor of 2. Now I'm going to see if I can factor this part. So I do factors of negative 4 that add up to negative 3. So factors of negative 4 that add up to negative 3 are going to be x minus 4, x plus 1 equals 0. So then you set each one of these factors equal to 0. So you do x minus 4 equals 0 and x plus 1 equals 0. So x equals 4 and x equals negative 1. You can't set, even though 2 is a factor, you can't set 2 equal to 0 because that wouldn't make sense. 2 can't equal 0. And then 29, again, I have this b term, so I can't just take the square root of both sides. So I'm going to see if I can factor this. So I do factors of negative 5 that add up to negative 5. So are there two numbers that when you multiply, you get negative 5, but when you add, you get negative 5? I can't. Okay, these two don't add up to these two don't add up to negative 5. So I could complete the square, but I'm going to do some examples of completing square. I could put in my graphing calculator, but we haven't done graphing calculator in Algebra 1. Or I could do the quadratic formula. So I'm going to do the quadratic formula. So A is 1, B is negative 5, and C is negative 5. So I'm going to do negative b, so 5 plus or minus the square root of b squared, put that negative 5 in parentheses, minus 4 times a, which is 1, times c, which is negative 5, all over 2 times 1. So then I simplify this. So this is going to be 25 minus negative 20. So that's 45. So it's 5 plus or minus the square root of 45 over 2. So we can break down the square root of 45. That is broken down into 3 root 5 over 2. So here are my two answers. My two answers are 5 plus 3 root 5 over 2 and 5 minus 3 root 5 over 2. Okay, for the next part, completing the square over here, what I started to do, so I already started to do this, but what you want to do to solve by completing the square is make sure you have a and b on one side and c on the other, which we do right here. Then to complete the square, what you're trying to do is you're trying to make it look like a problem up here where we took the square root. We have, this is called the perfect square, x minus 2 times x minus 2, because it makes a square if you think about the area. So down here, in order to complete the square, you take half of b and you square it. So in this case, half of 3 was 1.5 and I squared it. And I added it to each side. You need to add it to the right hand side and the left hand side to balance the equation. Then you take this part and you factor it. This becomes something that's factorable into a perfect square. So instead of thinking about factors of 2.25 that add up to 3, all you need to do is just take half of the b term, which is 1.5. So now you have this equation that you can solve by taking the square root. So I'm going to take the square root of this side and this side. So I'll have x plus 1.5 equals, but I run into a problem right here because I can't take the square root of a negative number and get a real solution. So actually this is going to be no solution. So this would be a parabola that opens up because this is a positive and it just doesn't cross the x-axis. There's no x-intercept, so there's no real solutions. So here I'll do another complete the square from the beginning to end. So what I want to do first is get a and b on one side and c on the other. So I need to get rid of the 4. So I have x squared minus 2x equals negative 4. Then I take half of negative 2 is negative 1 and I square it. So I'm going to add 1 to each side. Don't forget to add it to the left and the right hand side. Now this factors into a perfect square. So this is going to factor into, take half of negative 2 and write x minus 1 squared. So now you have something that you can take the square root of. So I'm going to take the square root of both sides. But again, I'm taking the square root of a negative number, so it's no solution. So the two problems I picked for completing the square actually turned out to be no solution, but that is the technique. And then down here, determine the number and types of solutions. This is when you're going to use the discriminant. So the discriminant is what is underneath the square root in the quadratic equation. So it's b squared minus 4ac. So if b squared minus 4ac is positive, there's going to be 2 real solutions. And if it's negative, if the number is negative, there's going to be no real solution because we can't take the square root of a negative number and get a real answer. And if the number is 0, there's going to be one real solution. There's going to be one x-intercept. So first I'm going to do b squared minus 4ac for each of these. Okay, so I did b squared minus 4ac. So the first one I had a, b, and c on one side. So I wrote a, b, and c. Make sure you plug in b squared in parentheses if it's a negative number. And I got 28. So that tells me it has two real solutions. It has two x-intercepts. Now I'm going to go ahead and finish and solve it. So remember the quadratic formula is negative b, so it's going to be 6 plus or minus the square root of b squared minus 4ac, which I got was 28, all over 2a. So you can break down the square root of 28. So it's going to be 6. Oh, I put 2a, but this should be just 2 because it's 2 times 1, which is just 2. So it's 6 plus or minus, if I break that down, it's 2 root 7 over 2. Now, because you can divide each of these by 2 and reduce it, I'm going to divide 6 by 2 and get 3. And I'm going to divide 2 by 2 and get 1. So that's just going to be root 7. So this is my answer here. So this is a parabola that crosses the x-axis twice. It has two solutions, and the two solutions are irrational numbers, 3 plus root 7 and 3 minus root 7. When I did the discriminant over here, I had I needed to get c over here, so that's why I wrote that c was negative 10. So then when I plugged it in, I got a negative number. So that means that there's going to be no real solutions. So the parabola doesn't cross the x-axis. And then over here, same thing. I had to get, this was my b term. I had to put it over here, which would make it negative. So then I plugged negative 6 squared minus 4 times 1 times 4. Oh, and this should be 16. So I get the square root of 20. So now I'm going to do negative b. So that's going to turn into a positive 6 plus or minus the square root of 20, because that right there is my discriminant. So it's 20 over 2a, which is just 2. So 20 can break down into 2 root 5, so it's 6 plus or minus 2 root 5 over 2. Now same thing, you can divide both of these by 2. So 6 divided by 2 is 3. And then 2 divided by 2 cancels out. We still have that root 5. So this is a parabola that crosses the x-axis twice. So it has two real solutions. And my solutions are irrational, 3 plus or minus root 5.